Hello everyone, welcome to Payment Tech Media. In this video we will go over another example of IPv4 Class C subnetting. In this example, they gave us one IP address and then they gave us the subnet mask and then they asked what is this address based on this subnet mask. So what we need to do first, we have to take a look at the IP address and then looking at the first octet. In this case, the first octet 192. 192, that's Class C. And what is default subnet mask for Class C is 255.255.255.0. That's a default subnet mask for Class C. It means the first, second, and the third octet belongs to the network and the last octet belongs to the host. Okay, now here they gave us this subnet mask instead of this. So we know they didn't use the default subnet mask. Therefore, this address with this subnet mask, this is classless subnet mask, not classful, not the default subnet mask. So this is not a default subnet mask. Now what is this address? So in order to find out the next step, it's basically converting this subnet mask into the binary and then writing down the binary format here to find out our cut line. So where is all the ones and where is the cut line, where is all the zeros? Okay, so the first octet here, 255, so if we erase this one, so the first octet in our subnet mask here, 255. This means all the 8 bits turned on. So in the first octet, all the 8 bits turned on. Because anytime in any octet, if we have all the 8 bits turned on, the decimal value is 255. Where this 255 is coming from, if we add all these decimal numbers. Because ones, we just need to add the ones that are already being turned on. In this case, 1 is on, 0 is off. So in this binary, 1 means on. And if you have any question regarding how to convert binary to decimal or decimal to binary, please watch my other videos. I have full video demonstration going over binary to decimal, decimal to binary, and different number systems conversions. Okay, so here the first octet 255, we have all the 8 bits turned on. The second octet 255, let's go over. We have all the 8 bits turned on the second octet. And the third octet 255, we have all the bits turned on for the third octet here. And then we have 240. So this 240, what does it mean? We just need to convert this decimal to binary, which again, it basically means that the first 4 bits turned on. If I quickly show you guys going from decimal to binary, so if we have our 8 bits, and decimal values 1, 2, 4, 8, 16, 32, 64, and 128. These are the decimal values, and where these decimal values coming from, all these decimal values, where they're coming from, it's basically 2 to the power of bit position. 2 to the power of bit position. And 2, why 2? Because of the binary. We have ones and zeros, which again, on the previous videos, I talked about a lot more in detail. So, but quickly to show you guys here, we have 240, we just need to write down 240. And then going from left to right. So we have to see if this number, 240 decimal value, if it's greater than or equal this decimal value, we just need to turn on. So in this case, 240, it is greater than 128. So this one is on. Now what is our new value? 128. If we take out 240 minus 128 is 112. That's our new decimal value. So 112, let's write down here. 64. Is 112 greater than or equal 64? It is greater than, so it's turned on. And what is our new value? Minus 64, which is 48. This is our new value. So I'm going to write down here 48. So this 48, is it greater than or equal 32? It is greater than, so it's turned on. So 32. What is our new value? 16. So 16, let's write down here. Does this 16 is greater than or equal this 16? It is equal, so it's turned on. Minus 16, it's off. Now this is our new decimal value. So is this greater than or equal 8? Pretty much it's not, so it's off. And what about for 4? Does this greater than or equal 4? It's not greater than or it's not equal, so it's off. Does this greater than or equal 2? It's not, so it's off. The rest of them pretty much is off. When we have 0, the rest of them is off. Okay, so for 240 decimal gives us 11110000 binary number. And if we use calculator, we can see as well. So let's change the view to programmer view and making sure decimal is selected. So decimal value of 240. And here we can see the binary number 11110000. Which again, on previous videos I talked about this more, how we can convert decimal to a binary or binary to decimal, or pretty much any number system how we can convert. Just to quickly show you guys, this is the binary for 240. Let's erase. So it is 1 1 1 1 and 0 0 0 0. So originally, for the default subnet mask of 192.168.1.47, because 192 is class C, the default subnet mask was 255.255.255.0. It means the first 3 octet belongs to the network and the last octet belongs to the host. But right now, with 240, it means that we basically borrowed 4 more bits, 1 2 3 4, right? So when we convert a 240 decimal to binary, this was our binary. Therefore our new cut line is this one. So we moved this original cut line from left to right. That's an example of subnetting. Anytime when we move this cut line to the right, and by the way, when we move it to the right, we will have less number of IP addresses and we will have more number of subnets. When we move the cut line to the left, we will have more number of IP addresses but less number of subnets. We will talk about it more. That's known as supernetting, when we move the cut line to the left. Right now we are moving this cut line, the original cut line, to the right. So that's subnetting. Okay, so what was the original question? They gave us this IP address and this subnet mask, and they said, what is this address? Is this a network address, IP address, broadcast address? What is this address? Let's find out. What we need to do, we have to start from the 0 network. And what is 0 network? Basically looking at the IP address and apply its default subnet mask, 192.168.1.47. The 192 is class C, so the 0 network for class C, we keep the network portion, and for the host portion we put 0. That's a 0 network. So for example, the 0 network for this address would be 192.168.1.0. This is the network portion, this is the host portion. For the host portion we just put 0. When we talk about 0 network address, this is an example of 0 network address. Okay, so what we need to do next, looking at these bits, the last bit that is turned on, what is the decimal value for the last bit that is turned on? In this case, this one is the last bit turned on, so the decimal value is 16. This is our network increment. On what octet? We are working on the last octet. The cut line here is on the last octet, network increment 16 on the last octet. So here, this is our last octet. So we are incrementing by 16, 192.168.1.16. Let's continue incrementing 192.168.1.16 plus 16, 32. If we continue incrementing by 16, so the next one would be 192.168.1.48. If we continue incrementing 192.168.1.64. Do we need to continue incrementing? We don't, because 47, it's already less than 64. We don't need to continue, but if we want, we just simply continue incrementing by 16 here for the next subnets. Now take a look at this address that they gave us earlier. So 1.47, 1.47, is it between 0.16? No. Is it between 16.32? No. Is it between 32.48? Well, it is. It's between 32 and 48, right? It's not in this one, because the 48 plus 1 is 49. So this 47 is one less, right? So therefore it's on this one. So, all right, let's see. Oh, okay, so if we talk about, this is the subnet of 1.32, what would the broadcast address? Always one less than the next subnet. So the next subnet, in this case 192.168.1.48. So one less IP address would be 192.168.1.47. And then any IP address here in this range, these are the available IP addresses. Therefore, this address 1.47 here is the broadcast address. This 192.168.1.47 is the broadcast address for 192.168.1.32 subnet address. So again, if we had the multiple choices, what is this address? Is this a network address? Is this an IP address? Is this a MAC address? Is this a hexadecimal address? Is this a broadcast address? The correct answer would be this is the broadcast address based on this subnet mask that they gave us. Now we can continue and write down the first available IP address, the last available IP address, and how many subnets we have, how many hosts we have per subnet. But they didn't ask that question. But to show you guys, the first available IP address in this subnet would be 192.168.1.33, and it goes to the last available IP address in this subnet would be 192.168.1.46, one less than broadcast. So how many available IP addresses do we have? Always we can count at the bottom going from right to left, starting with number 2, 2, 4, 8, 16, minus 2, 14. So these are the number of available IP addresses that we can have per subnet. Now number of subnets, we can apply the same counting going from left to right, starting with 2, 2, 4, 8, and 16. We don't need to do the minus 2 when we are counting the zero network as well. So it gives us a total of 16 available subnets. How do we know? If we are keep incrementing by 16, it will be total of 1, 2, 3, 4, 5, 6, 7, total of 16 available subnets. Also earlier we talked about the formula, number of subnets. It's basically 2 to the power of subnet bits, and number of hosts, 2 to the power of host bits minus 2, which in this case for number of subnets, 2 to the power of what? 1, 2, 3, 4, which gives us 16. And for the host, number of hosts, how many host bits do we have? 1, 2, 3, 4. So zeros, it's the host bits. And again, ones, network bits, and here, after the original subnet mask, when we borrow any bits from the host, these are known as the subnet bits, right? So these are the host bits, zeros represents the host bits. So how many? We have 4. So 2 to the power of 4 minus 2, total of 16, minus 2, we have 14. So 14 available IP addresses per subnet. And how many subnets we have? 16 subnets. Here we can see 2, 4, 8, 16, and number of hosts 2, 4, 8, 16 minus 2 because of the network address and a broadcast address. This is a broadcast address. Network address we cannot use and assign to the computers on the network. So these are the only available usable IP addresses that we can utilize and assign on the network. That's why we do the minus 2. So again, per subnet we have total of 14 available IP addresses. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.